So this video is going to talk about expected value and standard deviation. So when we talked about well, we didn't talk about expected value, but we talked about standard deviation of a data set, we were able to use the calculator to be able to do that. So what I'm going to do here, I'm going to show you how to do these problems first by hand, and then I'll show you how to do it in the calculator. So just a couple things to really keep track of with the expected value. Expected value is basically the mean. So if you want to think about expected value, just think about the mean. So the average. So how much am I expected to, what is the expectation of this particular outcome to occur? So how many siblings am I expected to have? I don't know. So this is this first problem. So here's the expected value. Mu, we've seen this notation before, is equal to the expected value. E just stands for expectation of x, our random variable x, is equal to basically just summing. So this weird notation, the summation of x times the p of x. Yes, this looks very scary. We will only do this once, and then we can just do it in the calculator. Okay, and then we have also the standard deviation. Okay, standard deviation is still sigma. We also call it SD of x is equal to this craziness. Typically, if you were to do this by hand, I would recommend doing this one as opposed to the other one, because this one's a little easier to work with. Okay. All right, so let me first do this by hand, and then we'll go ahead and do it in the calculator in the next video. So so let me go ahead and give you an example. So given the PDF, okay, so here's my probability distribution, P of x. Okay, so let's say you had 0, 1, 2, and 3. And then you want to put in probability 0.2, 0.1, 0.4, and 0.3. Okay. So the first thing that you want to be able to do with this PDF, show that it is a PDF. Okay, so show indeed that this, what you're working with, is a PDF. So one of the things to kind of know is that if you know that this is going to be a PDF or not is if they all add up to 1. So if I take 0.2 plus 0.1 plus 0.4 plus 0.3, okay, then all of this should add up to 1, which actually it does. So it is a PDF. That's all you have to show. Just show that the answers, the probabilities all add up to 1. That's how you show that it's a PDF. Okay? All right, so now let's go to part B. So part B is find the expected value. Okay, and whenever I say expected value, I'm just asking for the mean. Okay, so the expected value or the mean has a formula. Mu is equal to the expected value of x, which is equal to the sum of x times p of x. Okay, so what this is basically saying, this funky looking, scary looking formula, you're just going to take all of your x's and you're going to multiply them by the probabilities. So the first one is going to be 0, and I'm going to multiply it by 0.2. So 0 times 0.2. Okay, plus, that's what the summation means. I'm going to add the next set. Okay, 1 times 0.1. Okay, add the next set. Okay, 2 times 0.4. And then the next one. That's going to be 3 times 0.3. Okay, so now this is going to go away. And all I have to do is just multiply all this out. So I have in my calculator right here. You can't see it, but you can just put it in your calculator as well to make sure that we all get the same answers. I ended up getting 1.8. Okay. All right. So now that we have this this answer, that's just basically the mean. So the mean, the number of times that this will occur is 1.8, which is kind of close to 2. So, and you can kind of see it in the probability distribution function that 2 tends to appear the most. So it would make sense for the mean to be somewhere around 2. Okay, so now let's do part C. Okay, and part C says find SD of x. So find the standard deviation. Okay, and like I said before, I think the easier way to find the standard deviation is this, by using this formula. So sigma, which is equal to SD of x, is equal to the square root of the sum of x squares times p of x minus mu squared. Okay? So one thing to kind of look for is let's first start off by figuring out what this guy is, and then we'll figure out the other part. And the best way to do it is I draw a table. Okay? So x, let's first start off by putting in our x's. So if we put on our x's, if you look here, it's going to be 0 to 3. So 0, 1, 2, and 3. Okay. The next thing that we're going to do, we're going to square all of our x's. So 0 squared gives me 0. 1 squared gives me 1. 2 squared gives me 4. And then 3 squared gives me 9. Okay, so I squared all of my x's. Now, the next thing that I'm going to do is I'm going to multiply all of my x squares times my probabilities. I can take the x squared and multiply it by the probabilities. It's going to be 0 times, what was that probability? I think it was 0.2. Then you have a 1 multiplied by the probability, 0.1. Then you have 4 multiplied by that probability, that was 0.4. And then 9 multiplied by the probability, that's 0.3. Okay, so what is this going to give me? This is going to give me 0. This is just going to give me 0.1. This is going to give me 1.6. And this is going to give me 2.7. Okay. All right. So now that I have the multiplication of all of these probabilities, now the next thing to do is add them all up. Okay, so I'm going to add these guys. Okay, I'm going to find the sum. Okay. So the sum of, maybe I should write like this, of x squared p of x is equal to, so I'm going to add 0 plus 0.1 plus 1.6 plus 2.7. Okay, that's going to give me 4.4. So hopefully I did this right, and you can check my work. So 4.4. All right, so basically this guy right here is this part. Okay, so let me go ahead and plug it in. So I'm going to have square root of this guy, this whole thing is 4.4. Minus mu. What is mu? Well, mu was the thing that we found in part B. That's mu. Mu in this case is 1.8. So I'm going to take 1.8 and I'm going to square it. Okay? So I'm going to put that into my calculator. So I'm going to take the square root of 4.4 minus 1.8 and I'm going to square it. And what I'm going to get, let's round it to 2 decimal places. So it's going to be 1.08. Okay, approximately. So that's going to be the standard deviation. So yes, this one's a little bit tedious, especially if you have a lot more numbers, and it can get really, really crazy. But what I'm going to do in the next video, we're going to do this same problem, but now we're going to do it in the calculator.